On the Kaleidoscope by Sir David Brewster. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. On the Kaleidoscope, from A Treatise on Optics by Sir David Brewster. When two plane mirrors are combined in a particular manner and placed in a particular position relative to an object or a series of objects and the eye, they constitute the kaleidoscope, an instrument which I invented for creating and exhibiting beautiful forms. If AC, BC, for example, be sections of two plane mirrors, and MN an object placed between them or in front of each, the mirror AC will form behind it an image mn of the object MN in the manner shown in Figure 16. In like manner, the mirror BC will form an image MN' behind it. But, as we have formerly shown, these images may be considered as new objects, and therefore the mirror AC will form behind it an image MN" of the object or image MN', and BC will form behind it an image mn' of the object or image mn. In like manner, it will be found that mn" will be the image of the object or image MN" formed by BC, and of the object or image mn' formed by AC. Hence, mn" will actually consist of two images overlapping each other and forming one, provided the angle ACB is exactly 60 degrees, or the sixth part of a circumference of 360 degrees. In this case, all the six images, two of the six forming only one, mn", will, along with the original object MN, form a perfect equilateral triangle. The object MN is drawn perpendicular to the mirror BC, in consequence of which MN and MN' form one straight line. But if MN is moved, all the images will move, and the figure of all the images combined will form another figure of perfect regularity, and exhibiting the most beautiful variations, all of which may be drawn by the methods already described. In reference to the multiplication and arrangement of the images, this is the principle of the kaleidoscope. But the principle of symmetry, which is essential to the instrument, depends on the position of the object and the eye. This principle will be understood from Figure 198, where ACE and BCE represent the two mirrors inclined at an angle ACB, and having CE for their line of junction or common intersection. If the object is placed at a distance, as at MN, then there is no position of the eye at or above E, which will give a symmetrical arrangement of the six images shown in Figure 197, for the corresponding parts of the one will never join the corresponding parts of the other. As the object is brought nearer and nearer, the symmetry increases, and is more complete when the object MN is quite close to ABC, the ends of the reflectors. But even here it will not be perfect, unless the eye is placed as near as possible to E, the line of junction of the reflectors. The following, therefore, are the three conditions of symmetry in the kaleidoscope. 1. That the reflectors should be placed at an angle which is an even or an odd aliquot part of a circle, when the object is regular and similarly situated with respect to both the mirrors, or an even aliquot part of a circle when the object is irregular. 2. That out of an infinite number of positions for the object, both within and without the reflectors, there is only one position where perfect symmetry can be obtained, namely, by placing the object in contact with the ends of the reflectors, or between them. 3. That out of an infinite number of positions for the situation of the eye, there is only one where the symmetry is perfect, namely, as near as possible to the angular point, so that the whole of the circular field can be distinctly seen, and this point is the only one at which the uniformity of the reflected light is greatest. In order to give variety to the figures formed by the instrument, the objects, consisting of pieces of colored glass, twisted glass of various curvatures, etc., are placed in a narrow cell between the two circular pieces of glass, leaving them just room to tumble about, while this cell is turned round by the hand. The pictures thus presented to the eye are beyond all description splendid and beautiful, an endless variety of symmetrical combinations presenting themselves to view, and never again recurring with the same form and color. For the purpose of extending the power of the instrument and introducing into symmetrical pictures external objects, whether animate or inanimate, I apply the convex lens LL, figure 198, by means of which an inverted image of a distant object, MN, may be formed at the very extremity of the mirrors, and therefore brought into a position of greater symmetry than can be effected in any other way. In this construction the lens is placed in one tube and the reflectors in another, so that by pulling out or pushing in the tube next the eye, the images of objects at any distance can be formed at the place of symmetry. In this way, flowers, trees, animals, pictures, busts may be introduced into symmetrical combinations. When the distance EB is less than at which the eye sees objects distinctly, it is necessary to place a convex lens at E to give distant vision of the objects in the picture. See my Treatise on the Kaleidoscope. End of On the Kaleidoscope by Sir David Brewster.